Hello guys, and welcome back to chemistry class. This is another new episode on chemistry, and today we are going to be looking at Dalton's law of partial pressure. All right, so do not forget that this video tutorial, of course, is brought to you by the O3Schools JAMB CBT practice app. If you have been following our episode, you know that we're talking a lot about this app and how it can help you succeed in your JAMB, right? So if you stick to this app, stick to our tutorials, the sky is your starting point. All right, so I do not want to talk much about the app today because we have something at hand. So let's continue from where we stopped. Right, this law was formulated by a man called John Dalton, who lived from 1766 to the year 1844. So if you are very curious, you can calculate the number of years the man would lead. All right. So John Dalton's law of partial pressure states that each gas, let me just write it out so that you'll be able to follow it very well. He said that the law states that each gas in a mixture of gases exerts a pressure proportionate to the percentage of the gas in the mixture and independent on the presence of other gases in the mixture. All right, so let's go over it again. Please, if you have not liked this particular video you're watching now, if you have not given it a like, please just click on the like button just below this video. Just click on the like button. If you have not subscribed to this YouTube channel, you are missing a lot, because subscribing will make you be notified whenever we release a new video. Subscription is free, so just click on that red subscribe button, that one you are seeing right now below this video. Just click on the red subscribe button and you'll be notified immediately we release or publish any new video. Please join us. All right, so now Dalton's law of partial pressure, we say the law said that each gas in a mixture of gases, like if having a mixture of gases, right, exerts a pressure proportionate in a mixture. Please note here, as in a mixture of gases, right? Each gas in a mixture of gases exerts a pressure proportionate to the what? To the percentage of the gas in the mixture again, and independent on the presence of other gases in the mixture. Is very, very, very what? Simple as ABC. For some reasons, a lot of JAMB students tell me that they don't understand what the law. The law is very difficult, and how to solve questions on them are very difficult. Well, you have come to the right place, right? If you see very well here, we're talking about mixture here, right? We are stressing mixture because to show that gases what do not what partake in what in reaction. Gases do not react together, right? Gases do not what react together. All right, so we're stressing what mixture here to show that what gases do not what react what together. They do not what react what together. So that's why you see us using what mixture here, what mixture here, right? So the law says that each gas in the mixture of gases exerts a pressure proportionate to the percentage of the gas in the mixture and independent on the presence of other gases in the mixture. Simple as A, B, C. Now, if I've known that, then there are some words, there are some formulas that will help us in solving questions when it comes to Dalton's law of what? Of partial what? Pressure. One is, example, you have to know that what that PA plus PB plus PC is equal to P total. All right, you have to know this. Where PA, PB, PC are the partial pressures of gases A, B, and C, right? While what P total is the total pressure exerted by the what? By the gases. All right. So you can see the first formula here is the formula one. Is formula one. Just say this is what formula one. PA plus PB plus PC. It may even be other. There may be PD, maybe PE. So they can even put dot 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 to show that what they can be more than what 3 gases. They can be 5 gases, 50 gases. So in a mixture of what gases, PA plus PB plus PC equals what P total. The P total is what is the total pressure exerted by what by the gases in the what in the mixture, right? While PA and PB and PC are the partial pressure of what of the gases in what of the gases what in the mixture. Now, having on this first one, there's another thing we want to also know about formulas in solving questions under Dalton's law of partial pressure, and of course that would be mole fraction. Okay, let's talk about partial pressure first. How to calculate partial pressure. Partial pressure is what? Is mole fraction times total pressure, right? Partial pressure is what? Mole fraction times what? Total what? Pressure, right? So if you know what if you know the mole fraction of a particular gas and you know the total pressure, then you can be able to calculate the partial pressure of that particular gas. You get? So simple as ABC. But how do you find the mole fraction, right? Mole fraction is equals to what? It equals to what? Number of moles of a particular gas. So I will say of the gas of a particular gas all over total number of moles of gases in the mixture. All right. So I said here that the partial pressure is mole fraction times total pressure, and of course the mole fraction is the number of moles of a particular gas, right? All over our total number of moles of gases in the mixture. For example, if let's say we are looking for number of moles of gas A, right? Like this. So that will be what? Number of moles of A, right? All over Na, number of moles of A plus Nb plus what? Nc. That means if you're having ABC what gases, right? You're having gases ABC. Right? To find the number of moles of what? Of A, right? That would be what? Na all over what? Number of what? So to find the mole what fraction, rather not number of moles, sorry. To find mole fraction, because I'm looking at what? Mole fraction. So mole fraction of what? Of A, which is now XA, will be equals to what now? Number of moles of A all over what? Na plus Nb plus Nc. Are you together? So it's as simple as ABC. Partial pressure is mole fraction times total pressure, and then mole fraction is what? Number of moles of the gas over total number of moles of gases in the mixture. Then mole fraction, for example, of A, which is what? XA, will be what? Na all over what? Na plus Nb plus Nc. So if you have these formulas at the back of your hand, then of course there's nothing left that you cannot crush. All right. So let's go back again and say the law states that each gas in a mixture of gases exerts what? A pressure that is proportionate to the what? To the percentage of the gases in the mixture and independent on the presence of what? Other gases in the mixture. And I said that the reason we're using mixture here is because what? The gases do not what? React what? Together. Is to stress the fact that gases do not react together. They are mixtures. All right. So now I've given you some formulas that will aid you in what? In solving questions when it comes to what? Dalton's law of partial pressure. And another very important formula that we will need, of course, is what? We know that formula very well. That number of moles is equal to mass over what? Over molar mass. All right, we know this formula very well. The number of moles is what? Mass over molar mass. So it's going to be also useful or helpful when we are solving some questions that have to do with what? Dalton's law for partial pressure. So let's quickly take a question to what? To drive this point home, right? All right, so I'm going to what? Make this part very fast. I'm going to make it very fast so that what? We can come together, solve it, and the video will be done for today. Please, if you have not downloaded the O3Schools JAMB app, because this question we are going to solve is from the app. So, right, so get the app so that I can solve thousands of questions on the app. So this part is going to be very fast so that I can have a question on the board. So yeah, welcome back. All right, so we are giving a question on the board on Dalton's law of partial pressure, right? So it says 10 gram each of nitrogen, helium, and a third unknown gas of molecular weight 40. So we know the weight, we know the molar mass of the unknown gas, right? We know the mass, all right? Now we're put in a gas jar, right? Now they exhibited a total pressure of 440 millimeter mercury, and we have to determine the partial pressure of each gas. We're looking for what? Partial pressure of each gas. We know what partial pressure is. Partial pressure is what? Mole fraction times what? Times what? Total what? Pressure. So once we know the mole fraction, then we can be able to what? To find what? The partial pressure of what? Of each gas, because we know the total pressure already. All right. So let's head on to it. Right. We know that what? Total pressure is what? 440 millimeter mercury. That one is certain. All right. And then we know what? The mass of each of the gases. 10 gram of nitrogen, 10 gram of helium, 10 gram of the unknown gas. We know the molar mass of what? The third gas. We're giving nitrogen to be 14. You know, nitrogen is always like this, and 2. So to find the what? The molar mass of nitrogen will be what? 2 times 14, which will be 28 what? Right? 28. All right, now the helium is what? Helium is always what? He. That's so there's no 2 behind it, below it. All right. So there's no subscript of what? 2 there. That means the molar weight, molecular weight of helium will be 4. Then that of what? Nitrogen will be what? Will be 28. All right. Now we know that what? Number of moles is equal to what now? Mass all over what? Molar mass, right? So now we can find the number of moles of nitrogen, number of moles of helium, and number of moles of the what? Of the third unknown gas. So that I can find that is what? That is if we know the number of moles of each of them, we can now find what? The mole fraction. And then from mole fraction, we can now use the what? To multiply the total pressure to find the partial pressure of each of the gas. I don't know if you understand. Right now we know the total pressure, but we do not know the mole fraction of each of the what? Each of the gases. So we need to first of all find the mole fraction. Before we find the mole fraction, we need to find the number of moles of what? Of each of what? Each of the gas. We know the mass, and then we know what? We know the what? Total pressure. We know the mass, we know the what? The molecular mass or molar mass, and we know the total pressure. So we can find the mole fraction, then multiply each of the mole fraction by what? By the total pressure to find what? Our value. Now let's find the number of moles of each of the gas. Let me rule this so that I can conserve space. Number of moles of nitrogen will be equal to what now? Mass. What is the mass of nitrogen? 10 over what? That will be what? Molar mass of nitrogen, which is what? 28. If you do this value, reduce, I'm going to have 0.357, right? As the number of moles of nitrogen. Now, number of moles of helium. Helium mass is 10 also, because 10 gram each. Let's say 10 gram each of nitrogen, helium, and a third unknown gas divided by what now? 4. This will give us 2.50. All right, number of moles. That's moles. This will be moles. All right, then the number of moles of a third unknown gas. Let's say that gas is X. All right, we know the molecular weight to be 40, so we have 10 over 40. That will give us 0.25 moles. All right, so now we know the number of moles of what? Of each of them. Now, what about the mole fraction? How do we now find the mole fraction? We'd say that what mole fraction is what? Mole fraction is equal to what? Number of moles of the gas all over what? Total number of moles. Total number of moles of the gases in the mixture. All right, so we know this. We know that our mole fraction is number of moles of the gas of a particular gas divided by the total number of moles of the gases in the mixture. All right, so we have three gases here, N2, He, and X, for example, and we know the number of moles. All right, so now to find the what? To find the mole fraction, right, for N2 now, mole fraction, let me take this off. Mole fraction of N2 of nitrogen because of what now? What number of moles of nitrogen? 0.357. 0.357 over the total number of moles. Total number of moles will be what now? 0.357 plus number of moles of helium is what? 0.2, sorry, that's 2.50 plus 2.50, then plus what? Number of moles of X is 0.25. 0.25. So if we do this now, this will be the mole fraction for what? For nitrogen. So that will make our work very easy. We know that what to find what the partial pressure is mole fraction times total pressure. So we can easily what? Leave this part of it now, right? You can clean this part off so that first of all we find the total number of moles. Total number of moles because of what now? 0.357 plus 2.50 plus 0.25. We do that, I'm going to have 3.107, right? We know the total number of moles now. Moles. All right. Then to now find the partial pressure of what? Of nitrogen. Partial pressure of N2 because of what now? What is the number of moles of nitrogen? 0.357 divided by total number of moles 3.107 times what is the total pressure? Total pressure is what? Total pressure is what? Giving us what? 440 millimeter mercury in the question. I'm going to have 440. Right? If we do this, I'm going to have 50.56 millimeter mercury. All right. So it's as simple as that. We are doing this because partial pressure is equal to what now? Partial pressure is equal to mole fraction times total pressure. All right, it's as simple as ABC. So this is why we are doing this. The mole fraction is this one. This is the mole fraction for nitrogen, and this is total pressure, right? So if you multiply this value, this mole fraction times total pressure, you will know the partial pressure of what? Of nitrogen. I'm trying to skip a step here, right? Because I'm not teaching kindergartens. I know that you understand that very well. But if you don't understand for any reason, please drop a comment. All right. So now partial pressure of what? Of helium will be equal to what now? What is the number of moles of helium? 2.5. 2.50 divided by 3.107 then times 440 millimeter mercury. This will give you 354.04 millimeter mercury. All right. So now we have gotten the partial pressure of what? Of helium. We've gotten the partial pressure of nitrogen. Now we now find the partial pressure of the unknown gas X. Now partial pressure of X now because of what now? 0.25 divided by 3.107 then times 440. Right? So if you press the calculator, 0.25, you are going to have 35.40 millimeter mercury. All right. So it's very simple. So this will now be the partial pressure for what? For nitrogen, helium, and X. So I just brought this question so that you'll be able to use to understand how to calculate for partial pressure. So most time in an exam condition, you may just be asked to calculate the partial pressure of nitrogen, right? So if you find the number of moles first, then the mole fraction for nitrogen, then multiply by the total pressure. So your answer is just there looking at you, staring at you confidently. All right, so I'll go over this again. All right, please like this video. Make sure you like this video. All right, so I've said I talked about the Dalton's law of partial pressure. I gave you some formulas that we can use to solve questions under Dalton's law of partial pressure. All right, and then this is it. This is a typical question. It's a typical question, and then we have done justice to it. So you do not have any complaint about that law of partial pressure. Anyhow they said the question, you already know how to attack it. All right. So please do not forget to share this video to your friends, to your class group, to your classmates, and so on and so. For anybody that you know that are preparing for JAMB, please share this video to them. Do not forget to like the video and do not forget to subscribe. And as you do this, I'll see you in the next class. Thanks for watching.